In this video, we're going to solve a quadratic equation by completing the square. And we're going to solve two quadratic equations, both of which have a leading coefficient of 1. Now, when the leading coefficient is 1, all we need to do is remember what our strategy is. And our strategy is to take the left-hand side and turn it into a perfect trinomial square. To do that, basically, we remember the form. The left-hand side, we want to make it look something like this. X squared plus bx, and then whatever numbers, whatever other coefficients might be floating around on the right-hand side, we want to get them, on the left-hand side, we want to get them on the right-hand side. And then once we do that, then we are going to add b over 2 quantity squared. Of course, if we add it to one side, we have to add it to the other side. So that's our strategy. So let's do that for both of these equations. For the first equation, let's subtract 32. All right. Again, remember, we're going to replace that with something else. Minus 32. So this leaves us with a squared plus 12a equals minus 32. All right. So what do we replace it with? We replace it with this. B over 2 quantity squared. So B, in this case, is 12. That means that B over 2 is going to equal 12 over 2. This equals 6. So the quantity B over 2 squared is going to equal 6 squared. It's going to equal 36. So I'm going to add 36 to this side, and I'm going to add 36 to this side. Okay, so this is a perfect trinomial square, so I can write it as a, again, plus this, 6. The whole quantity squared is going to equal minus 32 plus 36, which is 4. So that's going to equal 4. Now I have the left-hand side as a perfect trinomial square. So that means I'm going to be able to apply the square root rule, which means I take the square root of the left-hand side, and of course I'm going to do the square root of the right-hand side. But because it's a square root, I recognize that there are going to be two solutions. Some number plus its opposite. Okay, so the square root of a square is just itself. They're inverse operations, so they cancel. And this is going to equal plus or minus the square root of 2. I'm sorry, plus or minus the square root of 4. My brain is going ahead of my mouth. Square root of 4. 4 is a perfect square, so its square root is 2. Solve for a, we're going to subtract 6 from both sides. And what do we get? Well, that's going to cancel. And we get a equals minus 6 plus or minus 2. Which means a equals minus 6 plus 2, or minus 6 minus 2. Minus 6 plus 2 is minus 4. Minus 6 minus 2 equals minus 8. All right, so let's check our solution. What was our original equation? A squared plus 12a plus 32 equals 0. A squared plus 12a plus 32 equals 0. So let's check our solution. Okay, and that means we're going to plug in minus 4, and then we're going to plug in minus 8. See if each of those solutions satisfies our equation. So that's going to be minus 4 squared plus 12 times minus 4 plus 32. And the question is, if I do that arithmetic, will I get 0? Well, let's see. Minus 4 squared is 16. Oops, plus times a minus is not a plus, it's a minus. 12 times minus 4. Well, 4 times 2, that's 8. 4 times 1 is 4. Plus 32. Does that equal 0? Let's add our two positive numbers. 32 plus 16. 2 plus 6 is 8. 3 plus 1 is 4. Does 48 minus 48 equals 0? Yes, of course they do. 0 equals 0. So minus 4 is in fact a solution because it satisfies the equation. Now let's see if minus 8 satisfies that equation. Minus 8 squared plus 12 times minus 8 plus 32. Does that equal 0? Minus 8 squared is 64 plus, again I make the same mistake. How's that for consistency? Plus times minus is minus. 8 times 2 is 16. 1 times 8 is 8, plus 1 is 9, plus 32. Does that equal 0? Again, we'll add our two positive numbers here. 32. 2 plus 4 is 6. 3 plus 6 is 9. Does 96 minus 96, does that equal 0? Yes, of course it does. That means that minus 8 satisfies the equation and is in fact a solution. So we check that is the correct answer. All right, let's do another one. Again, we start off by eliminating the 7 from the left-hand side by subtracting it from both sides. And we are left with t squared minus 8t equals minus 7. So what do we add in here that we'll also have to add there to make that a perfect square? Again, same process. B now is minus 8. So that implies that b over 2 equals minus 8 over 2, which is minus 4. That implies that b over 2 quantity squared equals minus 4 squared, which equals 16. So that means I'm going to add 16 here, and of course I have to add it to the other side to keep the equation in balance. Remember, Karahimi said that this technique was called completion and balance. And this is the completion on the left, and the balance is adding it to the right. Okay. Where were we? So this is a perfect trinomial square. And it's going to be t minus 4 squared equals minus 7 plus 6. That's going to be 9. So this is 9. I now have a perfect trinomial square on the left-hand side. So that means that I can apply the square root rule. The square root rule says take the square root of one side, and of course take the square root of the other side. But remember that when I take the square root, there's going to be two solutions. One plus, one negative. Both plus and negative are going to have the same absolute value. Anyway, again, the square root of square is itself. They cancel each other out because of inverse operations. So I have t minus 4 equals plus or minus the square root of 9, which is 3. Solve for t by adding 4 to both sides. And what do I get? I get t, that goes away, equals 4 plus or minus 3. All right, let's express that as individual solutions. So we get 4 plus 3, that's one solution for t, or 4 minus 3, that's another solution. 4 plus 3 is 7, 4 minus 3 is 1. Again, we want to check, what's our original? T squared minus 8t plus 7 equals 0. T squared minus 8t plus 7 equals 0. So let's check. So let's check for t equals 7. That's going to give us 7 squared minus 8 times 7 plus 7. Ooh, 3 7s. 7, 7, 7. That's a lucky day. Does that equal 0? 7 squared, that's 49. Minus 8 times 7, that's 56. plus 7. Does that equal 0? Again, we add the two positive numbers. 7 and 9 is 6, carry the 1. 4 and 1 is 5. Does 56 minus 56, does that equal 0? Yes, of course. 0 equals 0. So 7 is in fact a solution because it satisfies the equation. So now we're going to try t equals 1, and let's see if that works. 1 squared minus 8 times 1 plus 7. Does that equal 0? 1 minus 8 plus 7. Does that equal 0? 1 and 7 are 8. 8 minus 8. Does that equal 0? Yeah, you see it coming. 0 equals 0. That means that is a solution because it satisfies the equation. So what do? We took two equations that had leading coefficients of 1. We got rid of the constant. We replaced it with b over 2 squared in both cases. That gave us a perfect square. The perfect square allowed us to use the square root rule. Once we use the square root rule, we got the solution, check the solution, and we're done. Okay, next time we're going to solve a couple of quadratic equations where the leading coefficient is 1. And the trick is we need to reduce the quadratic equation to this form, and then we just do what we just did, which is, as you can see, is such a common strategy in mathematics. See if you can reduce a problem that you know how to solve, or you don't know how to solve, to a problem you do know how to solve. So we'll see you next time.